I shall advise and guide you how to get 100% marks on this chapter on moles. If the student just see our previous videos and this video, 100% marks are assured. Only difficulty is, if at all there is, and that is also not a difficulty, students should know the reactions, and reactions also are not given out of NCERT book. So students just read NCERT and some PYQs and these videos. So 100% marks in NEET, in IIT JEE mains, in IIT JEE advanced, in board exam, 100% marks are assured on this mole concept. Students, I am Professor Sudhir Kumar Tewatia. So this is in continuation with our previous video. So today we are solving some more PYQs from NEET, IIT JEE mains, and IIT JEE advanced and NCERT. So let us start from the beginning. The question 1. The molarity of HNO3 in a sample which has density of 1.4 gram per milliliter and mass percentage 63% is. We have to calculate the molarity. This molecular weight of HNO3 is given 63. So this question came in JEE mains January 2020. Answers are written here. So let's try this question straight away with the formula. This formula. So this formula I'll write here. M is equal to M percent B. B is M percent B is the percentage of the solute. DAB density of the solution. A and B both means solution. If it is only A, that means it is density of the solvent. Into 10 divided by molecular weight of solute. So straightway substitute these values. Percentage is given 63. DAB, what is given DAB? 1.4. This 1.4 gram per ml, that is equal to 1.4 kg per liter. Into 10 divide by molecular weight 63. So it is straightway 14 mole per liter. So straightway its answer. It is shown in books by the first principle, but we have short time in the exam. So straightway substitute these values in this formula: percentage, density and molecular weight. You may ask, sir, where from this formula is coming. So you can derive yourself and I can give you a hint. What is this molecular percentage? If I write mass fraction, so mass fraction here, suppose I designate by MF. So that will be MB, M percent B by 100. That is MF. So if I substitute here, so this will be M equal to MF into 100 into DAB into 10 MWB. So this is mass fraction. Mass fraction is WB WA plus WB, and this is MWB. This will remain DAB into 1000, 10 into 100. So what is this? This weight of the solute divided by the molecular weight. This is number of moles of the solute, NB. This is weight of the solute plus weight of solvent, divide by density. Because it is in gram, so we divide by 1000 also. So that becomes volume, volume in liters. So that is the definition of mole. Number of moles divided by the volume of the solution. That means moles per liter. So this derivation is simple. Proceeding reverse way, we can reach this formula. And from this, we can derive this. You try yourself. Last time I have shown you some derivations. If you fail, you can write in the comment box. Let's go to the next question. Just read the question carefully. 6.5 molal. Molal means small m. 6.5. KOH. What is KOH? K molecular weight is 39 plus 140 plus 16. So MWB 56 KOH. It is given, density is given, solution density DAB 1.89 kg per liter or gram per ml. Numerical value remains same. So again, this is a simple question. Substitute these values. We have to find molarity of the solution. So this molarity of the solution, use this formula. This is molarity. Substitute these values here. So that M is equal to, substitute the values, 1.89 divide by 1 by 6.5 plus 56 by 1000. So what will it come out? It comes out to be 9 mole. Third question, a solution of H2SO4 is 31.4% H2SO4 by mass and has a density of 1.2 gram per ml. The molarity of H2SO4 solution is, again we have to calculate molarity. This percentage given, this is similar to question 1. So use this formula. M is equal to 31.4 98. What is the density given? 1.25 into 10. So that is equal to 4. Simple. Similarly, let's warm up with some other question of, say, from easy questions. Let us take up first. Easy questions are from NCERT, from NEET. So let's finish them first, then we'll come to JEE advanced questions. This is from NCERT. The density of 3m solution of NaCl is 1.2 gram per milliliter. Calculate the molality of the solution. So in this, density molarity given, NaCl molecular weight, we know, density given, small m we have to calculate. So very simple, just use this formula. If I use this formula, m is given 3 equal to DAB. We have to calculate 1 by m plus molecular weight of sodium chloride 58.5 by 1000. Where is the density? 1.25. So simply we have substituted the values. DAB, density of the solution, 1.25. Molality of calculate, we have to calculate 1 by m from here. So it's very simple. You take it this side. Sorry. How to go back this? 1 by m plus 58.5 by 1000 is equal to 1.25 by 3, 1 by m, 1.25 by 3 minus 58.5 by 1000, and m is 1.25 by 3 minus 58.5 by 1000 whole inverse, whole raised to power 1. So that m comes to be 2.79 mole per kg of the solvent, molality. Let's solve this question. This is NEET AIPMT 2015. This is a NEET question. The mass of, what is the mass of precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% NaCl solution? So let us know. For this, you have to know the equation. Reaction. Reaction is AgNO3 plus sodium chloride. It makes the equation AgCl plus sodium nitrate. So we have to calculate the weight of this AgCl. So this is a simple, rather simplest equation. 1 mole of this, 1 mole of this gives 1 mole of this and 1 mole of this. So 1 mole of this is of the silver nitrate. So molecular weight of the silver nitrate, if we add all this, Ag is 107.8 plus NO3, N is 14, 16 into 3, how much? So this 16.9%, 16.9% number of moles of AgNO3 16.9% are in 100. What will be in 1000? That will be so much gram. Divide by 169.8. So roughly, because so 1 molarity is 1. Now calculate this 58. So similarly calculate for sodium chloride and sodium chloride. 5.83 divide by 100 into 1000. Why we are multiplying by 1000? Percent means out of 100, 5.8. Out of 1000 it will be 58. Divide by molecular weight of sodium chloride again is 58.5. So you can again presume 1 mole. So molarity of the solution, number of moles in 1 liter of silver nitrate 1 mole, in 1 liter sodium chloride 1 mole. But the volume is given 50 ml. 1000 ml 1 mole, 50 ml mole, 0.05 mole, 0.05, 0.05 mole, 0.05 mole. So what is the weight of 0.05 mole of sodium chloride? Calculate the weight. 107.8 silver plus chlorine 35.5, 143.3. It will give this much, 14 पंजे 70, 7 gram almost. This is a good question. Ammonia prepared by treating ammonium sulfate with calcium hydroxide is completely used by NiCl2 to form a stable coordination compound. Assume that both the reactions are 100% complete. If this much gram of ammonium sulfate, this much gram of nickel chloride H2O are used in the preparation, the combined weight in grams of gypsum and the nickel ammonia coordination compound thus produced is, this came in JEE Advanced, so we have to understand the question first. I have written the reactions here. Ammonia is produced by this ammonium sulfate and calcium hydroxide. They react, so they give 2 moles of ammonia, 1 mole of this, 1 mole of this, 1 mole of this gives 2 mole of ammonia and 1 mole of this. So I think equation is balanced. 2 nitrogen and everything. And this ammonia liberated here is used here with this nickel chloride. So nickel chloride reacts, 1 mole of this reacts with 6 mole of ammonia, and this gives this much compound. Now as the question says, and as the reactions also show, thus this 1584 gram of this compound, this molecular weight is 132, that means 12 mole. So 12 mole of this gives 12 mole of this gypsum, calcium sulfate, and 24 mole of ammonia. and then it is reacted by, it is given 952 gram of nickel chloride. That means molecular weight 238 divide 4 mole. 1 mole react with 6 mole, so 4 mole will react with 4 times 24 mole. So 24 mole ammonia here is fully used here, and this compound is fully converted to this. This compound is converted to this. Now I have left it blank, though it some water or something may be there, but we are not bothered about that. We are asked the combined weight of this and this. So at the last, combined weight of this 12 mole of this plus 4 mole of this. So 12 mole of this, molecular weight 172, this much. 4 mole of this, molecular weight is this much. So this is the answer. I again summarize this. Read the question carefully. The ammonia prepared by treating ammonium sulfate with calcium hydroxide is completely used by nickel chloride. To form a stable coordination compound, assume that both the reactions are 100% complete, and if this gram of ammonium sulfate and this much gram of nickel chloride are used in the preparation, the combined weight in grams of gypsum and the nickel ammonia coordination compound thus produced is this much. So this is the first reaction. Ammonia produced by 12 mole is 24 mole, and this also requires 24 mole of ammonia, total ammonia consumed. This consumed, so product here remains this much. In the second reaction, product remains this much, maybe some water is also there, but this and this weight is being asked. So 12 mole of this, 4 mole of this, so that is the answer. Now this is again JEE Advanced 2019. The amount of water produced in gram in the oxidation of 1 mole of rhombic sulfur by concentrated HNO23 to a compound with the highest oxidation state of sulfur is. So rhombic sulfur is this S8 treated with HNO3. This is the balanced reaction I have written. And this water, 1 mole of sulfur gives 16 mole of water. So simply weight of water is asked. So 16 mole of water is 16 into molecular weight of water, 288 grams. Now question 6. 500 ml of 0.10 m oxalic acid solution taken in conical flask is titrated against NaOH from a burette. What is the concentration in molarity of the NaOH solution? So here in titration, 5 values are given. It is your check which value will you take. Some student may argue they will take the average value. Well, but in my opinion, where in titration 3 consecutive values are coming same, so we should take that value 999. So we take the volume of this sodium hydroxide as 9. So equivalence formula we apply. Equivalence formula is concentration of the solution into the volume divided by this coefficient is equal to this molarity, yani concentration, into volume divided by this coefficient. So this gives molarity 0.11. Aluminium reacts with sulfuric acid to form aluminium sulfate and hydrogen. What is the volume of hydrogen gas in liters produced at 300 K and 1 atmospheric pressure when 5.4 gram of aluminium and 50 ml of 5 molar sulfuric acid are combined for the reaction? So this molar mass of aluminium, R, and all these are given. So here the reaction aluminium with H2SO4, this gives aluminium sulfate plus hydrogen. So 3 moles of H2SO4 react with 2 moles of aluminium. what is given here? 5.5 gram of aluminium. Weight of molecular weight of aluminium is 27. 27, 5.4 divided by 27, that is 0.2. 0.2 mole of aluminium. They require 0.3 mole of H2SO4. But if we calculate what are the moles of H2SO4, volume into molarity, that means 5 moles per liter. So how much will be there? 5 moles per liter. That means 1000 ml. So in 50 ml, 250 by 1000, 0.25 mole. So sulfuric acid is 0.25 mole, not 0.3 mole. So this will be limiting reagent. So 3 moles produces 3 moles hydrogen. So 0.25 mole of sulfuric acid, 0.25 moles of sulfuric acid will react with aluminium. Some aluminium will remain here unreacted, and this hydrogen will be produced according to the sulfuric acid limiting reagent. So 0.25 mole of H2SO4 will produce 0.25 mole of hydrogen. But he is not asking the mole or weight of the hydrogen. He is asking the volume. So for that we have to apply this formula, V is equal to nRT by P. So N is given 0.25, R is 0.082 given, temperature 300 Kelvin, atmospheric pressure 1, so it gives 6.15 liter. This formula I have given in the beginning. PV is equal to nRT. Students should remember this formula also. Mass fraction of B by A is equal to this by this, this by this, this by this. Usually in the exam, these ratios are given. The solute and solvent, mole ratio. Then weight ratio, solute and solvent. Fraction, mass fraction ratio, not the mass fraction. Then molecular weight ratio is asked, or some this mole fraction ratio is asked. So these are simple. If you want, I can derive, otherwise by the simple first principle or by definition you can derive very easily all this. Now this is interesting question of IIT, and I am civil engineer. We used to calculate this in BTech for the soil particles. There, so I am quite familiar with such numericals. It says silver atomic mass 108 gram per mole, has a density 10.5 gram per centimeter cube. The number of silver atoms on a surface area of 10 raised to the power minus 12 meter square can be expressed in scientific notation as this. We need not calculate y. Y may be anything from 1 to 9. 1 to 9, it can be anything. We have to calculate this x, that means order. This is called order of the numbers. So 10 raised to power how much? Value of x is. So let us solve this. Density is 10.5 gram per centimeter cube. So 1 centimeter cube weighs 10.5 gram. How much mole? Mole is Ag, silver, 10.5 divided by 108. Okay, this much mole. So how many atoms in 1 centimeter cube? Number of atoms, they'll be 10.5108 into 6.02 10 raised to power. This is Avogadro number. In 1 mole, so many atoms. In this mole, how many atoms? This atoms. So this 23 roughly, because in the exam we are not supposed to use and there's no need also to use calculator and all that. So we have to simplify the calculation, because simply we have to find the order, not the exact number. So we can write this in 1 centimeter. How many atoms? 10.5108, 6.02. We can write 10 raised to 21 into 100. This 10 raised to 23 I have written like this, 21. Why I have written this? Because I will be taking the cube root of this whole expression, and in cube root this should be divisible by 3. So that's why I have made it 21 instead of 23, and I have written 100. So roughly I 1 by 3 in 1 centimeter line, this much atom will be there. So this 100 roughly I can cross like this. It will be roughly something 60 cube root into 10 raised to power 7. 60 cube root is something less than 4 10 raised to power 7 atoms in 1 centimeter. This is 10 raised to power minus 12 meter square. That means 10 raised to power minus 6 meter. One side of this square is half of it. 10 raised to power minus 6 meter means in 1 meter there are 1000 mm. In 1 mm there are 1000 micron. So this means 1 micron. So in 1 centimeter this. So in 1 mm or in 1 micron, they will be less than 4 into 10 raised to power 7 into 10 raised to power minus 4. Why I have used my 10 raised to power minus 4? In 1 centimeter there are 10 millimeters, and in 1 millimeter there are 1000 micron. So 1000 into 10 raised to power 4 micron are there in 1 centimeter. So they will be around 4000 atoms, 4000 atoms in 1 micron. And in this side also suppose same square, 1 micron square, because this is equal to 1 micron square. So 4000 into 4000 roughly 16 into 10 raised to power 6. So in 1 micron square they will be less than 4000 square, 16 10 raised to power 6, 1.6 less than 10 raised to power 7. So 7 is the answer. It may be 1.6, it may be 1.5, 1.2, 1.1. No need to worry about that error, because we are not bothered. closed vessel of 1 mole of 23892 uranium, complete decay. This uranium decays to lead 20682. This side is written mass. Okay, this side is written proton charge. So this is 238 is mass, this is charge. It decays to 206, this mass, and 82, this charge. So this is uranium, this is decayed 206 Pb82. So let us write this equation. This is helium ion. When this decays, it gives this lead and helium ion, an electron. So let's balance top 238, 206. So 32 mass. So this is helium. Helium is 4 mass. 4 into 8, 32. So this is balanced top. Electron mass is 0. Charge is 92. Here it is 82. So 10 charge more. Here 82. Here it is minus 6 because electron has minus 6. And here it is 16. 16 into 16 minus 6, 10. So difference is 82 plus 10, 92. So this is balanced equation. So what is there? This is given with 1 mole of air, and now what is increased? This has decayed. 1 mole air is already there. 8 moles of helium gas has also come. So earlier gas 1 mole, after reaction 1 plus 8, 9 mole. Why 9 mole? Because 1 mole of air remains unreacted. So this is before the reaction also and after the reaction also. So 1 plus 8, 9 mole in the end, 1 mole in the beginning. So the vessel is a closed vessel. Volume is fixed. So pressure is directly proportional to the number of the moles. So moles have increased. So pressure will increase. P1 by P2, N1 by N2. So 9 times.